Hi, this is Mr. Parks, and I am going to go through the review with you. So it's very important, I think, that you understand the review to be successful on the district test. And we're going to start with number one. One skill you're responsible for is not drawing a red line. Sorry about that. Is being able to name the congruent triangle. So notice that all angles, like this angle equals this angle, this is 90, that's 90. This angle O equals angle P by the notation. The hypotenuse equals the hypotenuse, and each leg equals each leg. So I know the triangles are congruent. So I need to label them as congruent. Now, order matters. So if I go OG, so here if I go O and then the G, then I also need to do the same thing here. So I would start at the one with one angle, go to the one that's 90 degrees. So I'd go to P and then R. Okay, so I went OGD, OGD. I would do the same thing here and I'd say PRC. So this is PRC. Order matters. So O goes to P, O goes to P, yes. G goes to R, G and R are the same, they're both 90, and D and C would then be the same. All right, so this one, we start off with R. So I got R. R is right here. And then R goes to A. See, R goes to A. So R goes to A. So where would I start on the other one? I need to start at the angle that's between the notches of 2 and 3. 2 and 3, that'd be O. So I need to start with O. Okay. Go ahead and put that in there. O. Is that 0? O. I said O. And then I need to go and follow along on the one that has 3 notches to A. So mine would be O to E. So I went O to E. So I need to put O to E. So we went R, A, C. Now we're going to go O, E, G. Okay, so that's how you name triangles congruent. Refer to the figure shown. Which of the following statements is true? And notice that these statements are included for us to know. So what I would do, I would label the triangle. So they say TV. Where's TV at? I don't see a TV. Where's the program? No commercials. So they say that TV is congruent to WV. So they're saying, I don't like how large that is. A little smaller. So they're saying that TV is congruent to WV. So notice I used the notation that says the TV is equal to VW. And then it says that UV, this one, and I need to use 2 notches now, UV is congruent to XV. Okay. Ooh. So I got this side is equal to that side equal to that side. So we are trying to use a triangle congruence theorem or postulate to prove these triangles are congruent. To prove triangles are congruent, you need 3 pieces of information. I only know 2 currently, but you should also know, based off being in this class, that this angle and this angle are what we call vertical angles. So that angle equals this angle. And so using that put together, we have S, the included angle, and the side. So we have 2 sides with an included angle. And the way we write that is S, A, S. So by SAS, side angle side, if we know that side angle side equals side angle side, that is enough information to prove congruency. So I know it's either going to be SAS or SAS. So I know it's not C, and I know it's not D. Now let's look at the triangle. They both start with triangle TUV. So they go T, U, and then the V. So let me think. Actually, I struggle with this myself. So let's see, they're going T, and then which one would correspond to angle T? Would it be V or W? So which one corresponds to angle T? It definitely 100% is not V. That'd be this angle right here. So T would be the one that's between blue and nothing. So blue and nothing would be W. So I'd go to W. So if I go TUV, here I'd go WXV. So that looks to be B. The answer is B. For each pair of triangles, tell which postulates, if any, make the triangles congruent. So this is where we're going to use SSS, SAS, and so on. So let's look. First thing I know, I got 3 pieces of information. I have an angle. So I have this angle here. I have the angle right here. We know that that angle is congruent to this angle. Okay. And then I know, and we don't want to go this way because we would be skipping a side and an angle. It's okay to skip a side or an angle, but not both. So we know first an A, so we'll put A. So we got A, and then we know that this angle equals this angle. So that's another A. And then we know that side equals side. So putting all that together, I would say angle, angle, side. Okay, and sometimes people call it SAA. It really doesn't matter the order because you could call this side, angle, angle. Okay. Now, the common mistake might be to call this angle, skip a side, skip an angle, side, angle. You can't do that. So you want to start on either end and work your way to the middle. So you would also not start at T. All right, number 5. What do I know? I know, first of all, that side equals side. So that's an S. I also know that side equals side. And then finally, I know that this side is equal to that side because they're the same side. So is that enough to know? Yeah, by SSS. So the theorem says that if each side is congruent to the other side of the triangle, and you know all 3 sides are congruent, that is enough to prove congruency. Number 6. Let's see. I only know 2 pieces of information, but like I said before, you can almost always find your other piece here, vertical angles. So angle equals angle. Now we have S and S with an included angle. S and S with an included angle. So putting all that together, I'd get S, A, S. Here, I would have side, angle, side, because they share the same side. So I got side, angle, side, which is indeed one of our theorems. So side, angle, side. So I'm trying to go through all of the side, angle, side questions. For each pair of triangles, are they congruent? And if they are, write the triangle congruency statement. Write the triangle congruency statement and then give the postulate that makes them congruent. Okay. So looking at this, A, are they congruent? Well, we have S. We know this side equals this side. We know this side equals this side. And we also know that this side equals this side. So that'd be SSS. So by SSS, yes, they are congruent. So labeling those, you could really start at any point. Let's say let's do alphabetical order. Let's go EOL. So if I go EOL that way, then I would 100% have to start at E, because E and E would be the same. This is what we call a reflection. So we got E, and then we would still go to O, and then we'd go to V. Okay, you have to label it as EOV. Number 9, let's see what I know. I know that side equals side. And I also know, because they share this side, that side equals side. So I know it's going to have 2 S's. And then that's all I know. And I don't see any vertical angles anywhere. But I see this parallel symbol. And so what I'm going to do is I am going to see if possibly this is a transversal. So I got that line and this line are parallel. And then let me think of where to put that transversal. Oh, maybe this way? I could do prettier than that. Right there, possibly? Okay, yeah. Because if this is 2 parallel lines cut by a transversal, we learned in this course that this angle and this angle are on the inside on alternate sides. Those are called alternate interior angles, and they are congruent. So I have now SAS. Okay, SAS. And then just to make it easier to read, I'm going to get rid of all this to put SAS. So SAS would go here. And then A, yes, they are congruent. And then remember we said that this angle equals this angle. And so let's name them. We got EFG. The first triangle honestly doesn't matter how you name it, as long as you put the E and you start with the angle that E started with. So E went to F. So I need to, looks like, go from, and I'm going E away from the 1 tick. So E to the F. So that looks to be right here at H, but I'm not going to go that way. I'm going to go H, G, F. And then just to make sure, that can't be right because this has an F here and that has an F there. Let me think. E, F. So I'd go H, G. Yeah, I guess because those angles aren't, we're talking about this angle and this angle, which are not the same. So the F's do not have to be in the same spot. But G and F should be congruent. G and F are, so we're good. All right, we are going to finish 10 and 11, and then that will be it for this video. You can watch the next video to get the rest. But which theorem or postulate proves the triangle is congruent? Well, I have S and S. I have S and S. And I have A equals A. Now, you cannot call this SAS because the angle is not included. This is actually SSA. And SSA, and I like to think of it backwards. Anytime I see this bad word, it's called the donkey theorem, written backwards, and I know it's a bad word, oh no, I know that that is not a theorem to prove congruency. So on this problem, because this is angle side side, or SSA, which theorem or postulate proves the triangle is congruent? There is actually, there isn't one, because SSA is not a theorem or postulate to prove congruency, just not. SSA doesn't work. Now here though, I have angle equal to angle. I have side equal to side. And then I have angle and angle that are vertical angles. And I have to read it in the correct order. So this would go SAA, or you could say AAS. And let's think, AAS would be number one. That's my theorem or postulate. Some people spell that SAA, same thing. Number two, select the rigid transformation that has been used. So imagine I took this triangle. Do I need to reflect it over? Do I need to rotate it? Do I need to just move it? So looking at this, it almost looks like a reflection. If it was a reflection, then this side would equal this side. So it's not a reflection, but if you take this ABC triangle and you just turn it, it would end up like this, okay? So we would call this a rotation. And the key word there is rigid motion. If they ask about rigid motion, they're asking, is this a translation, rotation, or reflection? Now, what's the triangle congruency statement? I would say triangle ABC is congruent. See, I start at A, so I need to start at E, okay? And I went A to B. So I went from the one with the mark to the one that doesn't have a mark. So I need to go E to D and then to C. And I put E, oh, that should be an E, not an F. So E, D, C. And that would go for number 3. All right, I think that's enough to get you started. Again, I will make another video for the rest. That is all. Have a good day, and I hope to see you again. All right, bye-bye.